Hi everyone and welcome to my channel. My name is Mohammad Ismail. I am a third sem student in the Bachelor's of Engineering in Sri Venkateswara College of Engineering, and my USN number is 1VE23CD030 and my department is CSCDS, and today's subject is OOP Java and subject code is BCS306A. And once again, welcome back to the channel. Today, we are diving deep into a fundamental concept in computer science, that is recursion in Java. So, what exactly is recursion? In simple terms, it is a technique where a function calls itself, either directly or indirectly. Now imagine breaking down a big problem into smaller, simpler pieces. That's the essence of recursion. And we solve these smaller pieces using the same function and then combine the results to solve the original problem. Now let's talk about two crucial concepts. One is base case. This is the simplest instance of the problem that we can solve directly. Think of it as the stopping point. Without a base case, our function could call itself endlessly, leading to what we call a stack overflow. Next one is recursion case. This is where the magic happens. In this case, the function call itself with a slight modified input, bringing us closer and closer to the base case. Recursion can offer some real advantages. Let me see one by one. Elegancy. For certain problems, recursive solutions can be incredible, elegant and concise. Next, readability. Sometimes a recursive approach can make the logic of a problem much easier to understand. Next is natural representation. In this, some problems are inherently recursive in nature, like traversing tree data structure or implementing divide and conquer algorithm. However, there are also some drawbacks to keep in mind. One is stack overflow. As I mentioned, excessive recursion can lead to stack overflow errors. This happens when the system runs out of memory to keep track of all the function calls. Next one is performance overhead. In this, function calls have some overhead, and in some cases an iterative approach might be more efficient. Next is debugging challenges. In debugging challenges, recursive code can be a bit trickier than debugging iterative code due to the multiple function calls. Now let's illustrate this with an example, calculating the factorial of a number. Here, the recursive implementation, we have a base case. If n is 0, the factorial is 1, otherwise we corrosively calculate the factor of n minus 1 and multiply it by n. Here, another classic example is the Fibonacci sequence. The base case here are for n is equal to 0 and n is equal to 1. The recursive case involves calculating the sum of the previous two Fibonacci numbers. Now let's talk about a slight more complex example, the Tower of Hanoi. Here the goal is to move a stack of disks from one peg to another using a third peg with some rules. Rule 1 is only one disk can be moved at a time. Rule 2 is no longer disk can be placed on a top of a smaller disk. The recursive solution involves breaking down the problem into smaller subproblems. Now let's discuss a special type of recursion called tail recursion. In tail recursion, the recursion call is the very last thing that happens within the function. This has a significant advantages. Compilers can often optimize tail recursive function, reduce memory usage. Next is indirect recursion. Indirect recursion occurs when two or more functions call each others. Here function 1 calls function 2 and function 2 calls function 1. Now let's compare recursion with iteration. Recursion is elegant, can be more intuitive for some problems, but can have a performance overhead and may lead to stack overflow. Next is iteration, generally more efficient, easier to debug, but might be less intuitive for certain problems. So, when should you use recursion? Divide and conquer algorithms like merge, sort, and quick sort. Next, tree traversal. In this, in order, pre-order, post-order traversals. Next, backtracking algorithms, solving puzzles, finding all problem solutions. Next, problem naturally defined recursively, like the Fibonacci sequence and the factorials. Here are some best practices to keep in mind. Carefully define your base case. Ensure your recursive calls move toward the base case. Consider tail recursion for potential optimization. Next, be mindful of the potential for stack overflow. Next, use recursion judiciously, weighting its advantages and disadvantages for each problem. Now let me see the conclusion. Recursion is a powerful tool in our programming arsenal. By understanding its concepts and using it wisely, you can write elegant and effective solutions for a wide range of problems. Thanks for watching. If you found this helpful, please like and subscribe for more programming tutorials.